There is a terrifying fragility to the world we live in. We often view nature as this immovable, permanent force, mountains that stand forever, and rivers that will always flow. But the truth is much more volatile. An ecosystem is like a complex machine with a billion moving parts. If you remove just one cog, one gear, or one wire, the entire machine doesn't just stop. It begins to self-destruct. We have seen this happen time and time again. We remove a predator and the forest dies. We divert a stream and the valley turns to dust. But the reverse is also true. And this is where the story gets incredible. Just as removing a single creature can destroy a world, adding a single creature back can heal it. Today we are looking at 3 specific cases where the solution to a planetary disaster wasn't a new technology, a massive engineering project, or a billion-dollar government grant. The solution was biological. We are going to explore how 3 very different animals, one a mythic swarm in the desert, one a master engineer in the river, and one an apex hunter in the mountains, managed to do what humans could not. They brought the dead back to life. Our first story takes us to the edge of the Gobi Desert, into the heart of Inner Mongolia. This is the Dalit Banner. If you look at satellite imagery of this region today, you might see patches of vibrant green, agricultural miracles in a hostile land. But if you were to stand there in the late 1980s, you would have seen something very different. You would have seen a graveyard of sand. This was a place where the earth had literally died. The soil was so compacted, so dry, and so stripped of nutrients that it was essentially concrete made of dust. Nothing could take root. And when plants cannot take root, the wind strips away the topsoil, creating a feedback loop of destruction that turns fertile land into a permanent wasteland. For decades, humans tried to fix it. We threw everything we had at the Dalit Banner. We tried planting millions of trees, but they withered and died within weeks. We tried massive irrigation channels, pumping water in from miles away, but the sun evaporated it before it could soak into the ground. It seemed hopeless. The desert was winning. Then, in 1988, a suggestion was made that sounded frankly ridiculous. A Chinese scientist proposed that instead of heavy machinery, they should deploy rabbits, specifically the Rex rabbit. Now, on the surface, this sounds like madness. Rabbits are often considered pests. In places like Australia, they are an invasive species that destroys ecosystems. But the theory here was different. The problem in Dalit Banner wasn't just a lack of water, it was the soil structure itself. It was too hard. It couldn't breathe. So they released the rabbits. And what happened next, according to the accounts we have, was a biological chain reaction. The rabbits, driven by the instinct to survive in a harsh environment, began to dig. They didn't just scratch the surface, they burrowed deep. Imagine millions of tiny drills working the ground simultaneously. Every burrow they dug acted as an air vent, breaking up the compacted sand and allowing oxygen to penetrate deep into the earth. This aeration is the first requirement for life, but they did something else. As they foraged for whatever meager roots they could find, their biological waste began to accumulate. In a place devoid of organic matter, rabbit droppings became gold dust, rich pockets of nitrogen and nutrients that the sand hadn't seen in centuries. Because the environment was so harsh, there were virtually no natural predators. The rabbit population didn't just grow, it exploded. We are talking about exponential growth. Thousands became tens of thousands. The ground became porous. It became soft. When the rains finally came, the water didn't just run off the hard surface and evaporate. It soaked into the rabbit holes. It reached the deep soil. Dormant seeds, waiting for a chance, finally sprouted. Vegetation returned. And with vegetation came stability. The roots held the soil together, preventing the wind from stripping it away. Within a few years, the story goes, the Dalit Banner was transformed. Potato farming became possible. The local economy, once decimated by poverty, began to thrive, exporting thousands of tons of produce. Now, I have to pause here. This story is incredible. It is the perfect example of biological engineering. But we have to be honest with the history. There are almost no verified, peer-reviewed sources that document this specific 1988 event in detail. It exists as a sort of modern ecological legend, a story that makes sense scientifically, but lacks the paper trail of a university study. It is a mystery. Did the rabbits save the desert? The logic holds up, even if the records are dusty. But our next 2 stories do not require faith. They are documented, verified, and arguably even more impressive. We move from the sands of China to the high deserts of Utah, USA. The year is 2019. The American West is in the grip of a mega drought. drought. This is not just a dry summer. This is a systematic collapse of the water table. In the Price River region, the situation was becoming critical. The rivers were receding, turning into trickles of warm, stagnant water. This is a death sentence for the ecosystem. When a river dries up, the fish die first. Then the birds that eat the fish disappear. Then the larger mammals, the deer and the bears, have nowhere to drink. And perhaps most dangerously, the surrounding vegetation dries out, turning the entire valley into a tinderbox waiting for a spark. The risk of catastrophic wildfire was at an all-time high. The human solution to drought is usually to build a concrete dam. We trap the water, hold it in a reservoir, and ration it out. But concrete dams destroy habitats. Researchers from Utah State University had a different idea. They wanted to build dams, yes, but they didn't want to use concrete. They wanted to use biology. They brought in the beaver. The beaver is often called nature's ecosystem engineer, but few people understand exactly how sophisticated their engineering is. A beaver doesn't just pile sticks in the water. They are hydrology experts. When the researchers released these beavers into the Price River tributaries, the animals immediately went to work. They identified the pinch points in the stream and began to build. They felled trees and packed them with mud and stones. Here's the genius of the beaver dam. It doesn't stop the water completely. It slows it down. By creating a pond behind the dam, the beavers force the water to spread out sideways. It seeps into the ground, recharging the aquifer, the underground water storage that humans can't easily reach. In Utah, the results were staggering. While the main river channels were still struggling with drought, the areas around the beaver dams remained lush and green. The ponds acted as fire breaks. If a wildfire swept through, these wet zones would stop the flames dead in their tracks. The water in these ponds was deeper and cooler, providing a survival bunker for fish populations that would have boiled to death in the shallow main river. The biodiversity spiked. However, this was not a fairy tale. Nature is brutal. Relocating animals is incredibly difficult. Many of the beavers released in 2019 did not survive. Some were taken by cougars, others simply couldn't adapt to the new terrain and perished. It was a risky gamble with a high casualty rate. But for the colonies that did establish themselves, the impact was profound. They took a dying, drying river system and turned it into a sponge that held water when the sky refused to give any. They proved that sometimes, to save a river, you have to block it. And this leads us to our final story. The most famous, and perhaps the most misunderstood, example of ecological restoration in history. We are going to Yellowstone National Park. Most people know that wolves were reintroduced to Yellowstone in 1995, but very few people understand the specific mechanics of why it mattered. This isn't just a story about wolves eating elk. It is a story about how a predator can physically change the geography of a river. Let's go back to the early 20th century. By the 1920s, humanity had successfully eradicated the gray wolf from Yellowstone. We viewed them as villains, monsters that killed livestock and game. We thought we were doing the park a favor. We were wrong. With the wolves gone, the elk population lost its only serious predator. They didn't just increase in numbers, they became lazy, they became comfortable. An elk that isn't afraid of being hunted doesn't need to move. They could stand on the banks of the river for days, eating every single sapling that tried to grow. For 70 years, the elk grazed the park into the ground. They ate the young. Willow trees. They ate the aspen. They ate the cottonwoods. The consequences were devastating, but not in the way you might think. It wasn't just about the trees. It was about the water. Without the trees on the riverbanks, the soil began to erode. The riverbanks collapsed, making the channels wide and shallow. Without the shade of the trees, the water temperature rose. Cold water trout began to suffer. And because there were no trees, there was no wood. And because there was no wood, the beavers, the heroes of our previous story, vanished. They starved to death or moved on. The entire architecture of the park collapsed. Enter the wolf. In 1995, we brought them back. The immediate effect was obvious. Wolves killed elk. But the secondary effect was the game changer. Ecologists call it the landscape of fear. The elk realized they were being hunted. They could no longer stand still in the river valleys. They had to move. They had to retreat to higher ground and denser cover to feel safe. For the first time in decades, the riverbanks were left alone. Almost immediately, the willows began to grow. The aspen shot up. Within a few years, there were forests standing where there used to be barren grass. And then the magic happened. The birds returned to nest in the new trees. The berries grew on the bushes, bringing back the bears. And most importantly, the beavers came back. They found the new wood and they began to build. The beaver dams slowed the river. The roots of the new trees Rains stabilized the banks. The river channels narrowed and deepened. The water cooled down. The fish recovered. Think about that chain of events. We dropped a pack of carnivores onto a mountain, and the result was that the rivers changed their course and the water became cleaner. It is a phenomenon known as a trophic cascade, an ecological process which starts at the top of the food chain and tumbles all the way down to the bottom. These three stories, the rabbits of China, the beavers of Utah, and the wolves of Yellowstone, tell us something profound about our place in the world. We often try to manage nature as if we are the masters of it. We try to use concrete, chemistry, and machinery to force the land to do what we want. But nature has been engineering itself for millions of years. It has a toolkit far more advanced than anything we have invented. Sometimes the best way to fix a broken world isn't to build something new. It's to simply put back the pieces we took away. Whether it is the aeration of the soil, the management of the water flow, or the control of the herd, the animals know what to do. They just need us to let them do it. If you found these stories of restoration fascinating and you want to learn more about the hidden mechanics of our planet, make sure to hit that subscribe button. We are digging up new stories every day, and you won't want to miss the next one. Thanks for watching.